Hello everyone, I'm Brendan. You might know me as Arga Pro on the audio forums. I want to make this video today just to kind of explain why I made the measurements that I made, or the methods that I picked for experimenting with different construction methods for speaker boxes. It's, when you try to explain these things on the internet, people learn the best from seeing somebody explain it and seeing them demonstrate something. So it just seemed like a video would be a lot more useful way to kind of get across some of the details of what I'm doing that gets lost in a wall of words of a post that I might put up. So I wanted to test a bunch of different materials and methods for making a box. One of the first questions I started with is, should I use an accelerometer? That seems like the obvious thing that a lot of people do. And then I thought, well, okay, so I have a square piece of material, a panel, and I stick it in a vise. Okay, is that the same as a box that's got glue all the way around the edges that's connected to the rest of the structure? I don't know, maybe not. And then might have a brace in the middle. How do I do that? And the more I thought about it, it just, struck me that if I want to do a single material compared to other materials, yeah, maybe you could do that. But what if you want to compare the material itself versus what does bracing do compared to just changing materials? Or what does driver mounting isolation do just compared to a different material or to bracing or something? And then the other thing with the accelerometer, and this was kind of the definitive decision. I have no idea what those squiggles mean from an accelerometer. I get that if they're smaller and they decay faster, that's probably a better material. At least it's more damped. But at the end of the day, I'm a human being. I hear sound waves hitting my ear, just like sound waves hitting a microphone. And to me, it just made the most sense that I want to actually measure what this box, this material is radiating, because a squiggle doesn't tell me if it's in a certain frequency, a bunch of frequencies. Is it broadband? I don't know. And so that was kind of the main reason for basically not using an accelerometer. Okay. I'm going to measure with a microphone. I'm going to measure SPL, and I'm going to build a speaker, right? Because this is going to be the most realistic match to what we're actually building at the end of the day. It's a pretty large stand mount, right? So I wanted something that was bigger than a bookshelf, because they have really, really small spans. So obviously they're going to be stiffer already. Is that a benefit? Is it going to, anything I learned carry over to, say, a tower speaker? Well, maybe not. So I try to make it fairly large box, but not waste a bunch of material doing so. And then driver mounting. So at first I thought, okay, now I got a box, I'm gonna build a box. So it is realistic. Where do I put the driver? Because I already know that if you have the driver on the outside of a box radiating, the response is just going to be swamped by that. Now, that's not to say that you're not going to hear problems, because if you have distortion at 10 decibels down, you ain't going to see it in the frequency response, but you're going to hear it. Or certain resonances are the same way. We'll go to Aaron's Audio Corner. He'll pick out every now and then he hears something weird in the upper end or in the mid range, and when he goes to look at his measurements later, you can kind of pick out a wiggle at 500 hertz. And if you hadn't heard anything ahead of time, or I should say, if you looked at the graph ahead of time and you seen the little wiggle, well, are you going to really say that's audible? All speakers have a little wiggle. They ain't perfect, but some of them are audible and some of them aren't. And so it struck me that I needed to have the driver inside the box. Okay. So then next question, I need to get a driver inside it, or, put it in and have a door, some removable panel that I can dismount it and mount it. So now what? So maybe I take this top panel and I make that screwed to the box, you know, with a foam seal around. Okay, then the first question is, this is a structural part of the box. Is that going to change things? You know, because now it's not glued like the rest. I don't know. Maybe it will. It's not. It's kind of getting away from having a realistic example. So the more I thought about it, and then the other thing was, okay, so maybe I have a divider in the middle. That was the plan. Mount the driver to the divider. Is that really the same as mounted to an outside surface? You know, I don't know. Now it's just got the edges of that divider connecting it to the rest of the structure to transmit that sound. Whereas when it's mounted onto a big surface like this, it's got this whole, at least this whole surface. So then I decided, well, I'm going to mount it on the outside. Okay, so how do I mount it on the inside and still have it mounted on the inside? Well, that's when I decided I'm just going to mount it on the outside and make a little box. Okay, and it just goes right over the top. You might not think that this is the same thing as what I just explained, my original idea, but it really is, right? It's mounted inside. And the other thing is, at least in this way, the back wave is going into an enclosure that's much smaller, at least surface area wise. And so maybe it radiates less sound. I mean, you know, some people have pointed this out when you get into the advanced FEA modeling on this sort of thing. You know, you got it, your surface area matters. So it's small, 3/4 MDF. And I put Resonix on the outside right away. I'm glad I did that because I found out this is pretty useful stuff. Just to kind of minimize anything that might be coming from here. Okay. And the other idea I had was, you know, maybe the little source driver here is mounted to this right off the bat, and then I can just swap it on and off boxes. But again, I want to stay realistic to what we actually do. What we actually do is we, even with a gasket or not, but with a gasket, we still fairly rigidly mount these with screws to the surface. So I wanted to do that. So, you know, continuing being as realistic as possible. And then mic placement. So where do I measure this box? Do I measure it close, far field? You know, we know the nearer you can get, the more you can get a higher signal to background noise. So I tested a number of different distances away from the box. I put those results, I think, in probably my first post of my thread on DIY audio. And it surprised me a little bit that there was so little difference, actually. I mean, you kind of had to get out, I think, a foot before things kind of changed a little bit, but really from a 1/2 inch, I think I maybe started an 1/8 inch, out to there, it's basically the same character of the frequency response curve, you know, just a little lower in level. And then as I got out farther, you kind of lost a little resolution, and then more room reflections start to get in. So it just, I go a 1/2 inch from the surface at the center that I mark, because it actually worked. It, you know, seems to work as well as any other distance. It captures the character of the radiation as far as I could tell. I do think that it's probably pretty important to always go to the same place. This was another reason I didn't use an accelerometer. They're absolutely notorious for having different responses by moving them an inch to the left the last time where you measured it. They just had different, and just taking it on and off onto the same spot can change the response. I seen one channel on YouTube use some adhesive tape, double-sided adhesive tape to stick it. But then he put another piece of adhesive tape over the original piece of adhesive tape. The second time he put it on there, they're really sensitive, and they're just a lot of problems. They're just hard to get consistent, repeatable results. And when I checked with even a microphone, you do see that with this. It's important to stay in the same spot. Okay, so there's that. Also, why the little bitty driver? This is a Peerless 830-970. And I picked this because I wanted something that was really broadband. Like if I picked a tweeter, I mean, you're not going to know anything below 1 or 2,000 hertz. So I wanted something that was really broadband. This has a very smooth response from 200 hertz up to 20,000 hertz or something. And it has surprisingly decent nonlinear distortion performance and Xmax for a driver this size, which is kind of important when it's inside, right? So you got to turn up the volume a little bit to get good signal to noise at your microphone measuring on the outside. And that was the other reason too. I did not pick like a larger woofer because they have their own breakup probably right in the band that I'm measuring, and then they roll off at higher frequencies, and I really had no idea what I was going to see. And so I just wanted something that, 200 to 20,000 hertz was reasonably flat. I'm feeding the whole box with about the same amount of energy, and so whatever I measure coming out of this box is what's coming out of this box with a real speaker. Okay. So I think that's probably all I'm going to cover on the box. I'm going to make another video, I think, going over my driver gating and then how to read the plots that I made. All right. Thanks, guys.